Hello everyone and welcome back to the channel. In this video, we will learn about NumPy. So NumPy is a Python library for numerical computing widely used in science and engineering. It's the go-to tool for handling numerical data in Python. It forms the foundation of many other Python packages like pandas, scipy and scikit-learn. And it is also very essential in various fields including data science, machine learning and image processing. So NumPy offers multi-dimensional array and matrix data structures. ND array is a key object representing homogeneous n-dimensional arrays. NumPy provides efficient methods for array manipulation and operations. It also enables a wide range of mathematical operations on arrays. NumPy enhances Python with efficient array and matrix calculations. It also includes a vast library of high-level mathematical functions for arrays and matrices. So now, how can we install NumPy? So if we already have Anaconda or Python installed in our system, then we can simply give the command conda install numpy, or we can also give pip install numpy. We need to make sure that we have Python in our system. And now we will see what are the difference between a Python list and numpy array. So NumPy basically offers fast and efficient methods for array creation and manipulation. Arrays in NumPy require homogeneity, unlike Python lists, which can contain mixed data types. So homogeneity basically ensures efficiency in mathematical operations on arrays. NumPy arrays are faster and more compact compared to Python lists. They consume less memory and are more convenient to work with. Also, NumPy efficiently stores data using less memory than Python lists. NumPy provides a way to specify data types, optimizing code for further efficiency. Now, let's start with some examples. So first of all, let's see how can we create a NumPy array. To do so, first of all, we need to import the NumPy library. Once we are done with this, then we can simply give the function numpy.array and we can pass in a list here. So once we do this, we can see it creates a NumPy array. And this is a one-dimensional array. So when we print the type of this array, you can see that we see it's a class numpy.nd array. Now let's see how can we create a certain certain types of vectors, one-dimensional and multi-dimensional using NumPy. So the first type is to create a NumPy array of zeros. So to do so, we can just simply give the function zeros and we can pass the shape of the expected array here. So here we can see that it creates an array with 5 elements in it. Again, if we want to create a multi-dimensional array, then we have to give the shape or the dimensions of the expected array. So here we have given 4 and 5, and this creates a multi-dimensional array which has 4 rows and 5 columns. Now we can also create a NumPy array of ones. Basically, this type of array will only contain one value, which is ones. So to do so, we can simply pass in the shape inside the ones function. So here we have given 5. So it creates a uh, basically it creates a array of length 5. Again, we can also create a multi-dimensional array. So again, we need to pass the shape here in the ones function. So here we are given 4 and 5. So it creates 4 rows and 5 columns. Now, NumPy also has something called as an empty function. So basically, empty function is like unlike zeros, which initializes the array with zeros, or the ones function, which initializes it with ones. The empty function does not initialize the array values. Instead, it allocates memory for the array without initializing the elements. So the array will contain whatever values were already in that memory space. Also, since the empty function does not initialize the array values, it can be faster than other array creation methods like zeros and ones, especially for larger arrays. So here we have passed this shape here inside the empty function, and it has created an array with 5 elements in it. So basically, it does not initialize the values. So initially, it will take the random values, whatever value is present in that particular memory space. Now we can also create an array with a range of elements. For example, if we have to create an array in which we want values in the range of 0 to 6. So basically the array should have only values between 0 to 6. So here we can pass the basically the range here in the a range function. And here we can see that it has created an array with values between 0 to 6. We can also reshape this array, which we created using the a range function. So here we can see that we have reshaped this array into a 2 by 3 matrix. Basically, it has 2 rows and 3 columns. Similarly, we can also reshape into this into a three-dimensional vector using the reshape function here. Now, we can also create an array comprising evenly distributed values within a specified range. So basically, let's say we want the values inside the array to be in the range of 2 to 18, but we also want the values to be distributed, basically evenly distributed. So here we give the starting point of the range, ending point of the range, and we also give the step size here basically. So if we look at the parameters available here. So it says start, stop, and the step size. So basically 2 is the start point, 18 is the end point of the sequence, and 3 is the step size. So it'll generate numbers in this range with a difference of 2. Sorry, 3. So here the first number was 2, and then after a difference of 3 numbers, it generates the next number as 5. Again, after a difference of 3 numbers, it generates a number 8. And this is done using the step size basically. We can also create an array where the values are evenly distributed within a given interval in a linear manner. So to do this, we can use the function linspace function. So here we give the starting point of the sequence, ending point of the sequence. So basically this means that we want numbers to be in the range of 0 to 10, and also how many numbers we want in that particular range. So here we can see we have the starting point as 0, the ending point as 10, and we have got 3 numbers in this array which we created using the linspace function. Also, we can also change the data type of the values inside the array. So by default, it's floating type. We can also change the data type, and here we have given the int type. So once we do this, we can see that the data type basically is being shown as int64 here. So next, we will look at arithmetic operations on NumPy arrays. So first of all, we have created one array in the using the arrange function, and the values are in the range of 1 to 6. We have created another array in the range of 1 to 10 with a step size of 2. So now we will perform some arithmetic operations on these two arrays. So first of all, we do a subtraction. One thing to note here is that the arithmetic operations in NumPy basically is of element-wise operation. So for example, if we give array 2 minus array 1, it will subtract the elements in these two arrays element by element. For example, 1 minus 1, 0, 3 minus 2, 1, 5 minus 3, 2, 7 minus 4, 3, 9 minus 5, 4. So it's an element wise operation. Basically, the operation is done on every element of both the arrays. Now next we can try the multiplication operation here. So we have taken array 1 and we have given multiplied by 2. So here also it takes every element of this array and multiply every element by 2. So here we can see that 2 multiplied by 1 is 2, and also 2 multiplied by 2 is 4, and so on. Next, we can see the power function, basically power operation here, where we are basically taking the array 1 and we are finding the squares of every element in this particular array. So here we can see it finds the square of every element. So the square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and square of 5 is 25. Next, we can see the dot product. So to do the dot product, we can also use this at the rate, basically at the rate key here. So we will take both the arrays and we'll do a dot product here using the at the rate key. Or alternatively, we can also use the dot function here. So we'll take the first array and use the dot function and we'll pass in the second array. So it gives the dot product of these two arrays. Now, NumPy also provides certain universal functions like exponential, square root, add. So basically, when we provide these functions with NumPy arrays, it performs these operations on every element of that particular array. So here we have taken this array 1 and we have passed into the exponential function, and it gives the result basically by finding the exponent of every element in this array. Also, we can use the sqrt function. So this function basically calculates the square root of every element in an array. So here we have used the array 5, so this array, and we are finding the square root of every element. So here we can see the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. Also, here we can see the add function where we are passing two arrays and it is performing the element wise addition of these two arrays. So we have passed array 1 and array 2 here. So if we look at it, so array 1 and array 2, 1 plus 1 is 2, 2 plus 3 is 5, 3 plus 5 is 8, 4 plus 7 is 11, and also 5 plus 9 is 14. And here is the results. So basically this also performs element wise operations on the provided arrays inside the add function. So this was an introductory video on NumPy. I'll be uploading more advanced and complex topics in NumPy in the upcoming videos. But that's all for this video. I'll be putting this Jupyter notebook in the description. Please like the video and subscribe the channel.